Hello, everyone, and welcome back to CloudBridge Tech Labs. I'm absolutely thrilled to be your guide today as we tackle a pretty monumental milestone in your training. This is Phase 1, Session 10, focusing entirely on SSL/TLS foundations. Now listen, this isn't just recommended viewing, okay? Completing this mandatory explainer is your direct ticket to unlocking the next phase of your learning journey. So let's build that operational confidence right here, right now. Okay, let's dive into this. Here is our agenda for today. Number 1, plain text versus encryption. 2, important security terms. 3, the simplified handshake. 4, troubleshooting errors. And finally, the DevOps stakes. Remember, mastering these 5 points is literally your roadmap to passing this phase. Section 1, plain text versus encryption, the HTTPS difference. And this brilliantly illustrates the whole fundamental premise of our explainer today. SSL and TLS provide the absolutely essential encryption for HTTPS. Without them, the modern, secure web just doesn't exist, period. Think about a flow without SSL. Your browser is sending data in plain text right directly to the server. It is essentially like sending a highly sensitive message on a completely naked postcard. Anyone, and I mean anyone, handling it along the way can read exactly what's written on it. It's totally vulnerable. But then, with SSL in place, that flow changes into encrypted data. Instead of that naked postcard, it's like you've locked your message inside an impenetrable, heavy-duty safe before sending it out. Even if someone manages to intercept the transmission, the contents remain entirely hidden. Section 2, important security terms, the vocabulary. Okay, so to understand exactly how that lock safe works, we first have to make sure we're speaking the same language. First up is the SSL certificate. Think of this as your identity proof. It acts exactly like a digital passport or maybe an official ID card, but for a website or a server. Because before you hand over any secure information, you need definitive proof of who you're actually talking to, right? Well, the SSL certificate is the mathematical guarantee of that identity. Next up, we've got TLS, which stands for Transport Layer Security. The big takeaway here? This is the modern secure protocol. You know, everyone in the industry still casually tosses around the term SSL, but TLS is actually the upgraded, highly secure protocol we really use today to establish these protected connections. It's the modern engine under the hood. Finally, the handshake. This is your secure connection setup. It's that initial, absolutely critical negotiation phase between a client and a server. It sets all the ground rules and establishes trust before a single piece of actual data ever gets transmitted. And you know, this sets the stage perfectly for the step-by-step breakdown we're going to look at next. Section 3, mechanics, the simplified SSL handshake. Let's move to and see how this builds out practically. All right, let's walk through a day in the life of a secure packet. It basically happens in 4 simplified steps. Step 1, your browser reaches out, contacts the server, and basically says, hey, I want to set up a secure connection. Step 2, the server responds by sending back its SSL certificate, its digital passport, like we talked about earlier. Now, step 3 is the make or break moment. The browser verifies that certificate. It's checking the expiration date, the issuer, making sure the identity proof is 100% valid. If something looks sketchy, it will not proceed, period. But only after that verification passes do we hit step 4, where secure encrypted communication finally kicks off. The safe is locked, your data flows securely, and the craziest part, this entire negotiation happens in mere milliseconds. Section 4, real-world troubleshooting, checking SSL. So it's time to transition from the theory into practical application, which is a massive part of your Phase 1 training. I literally want you to burn this command into your memory. Open SSL, S-Client, -connect, followed by your domain and port 443. By running this right in your terminal, you are manually triggering that handshake we just broke down. It lets you inspect certificates and troubleshoot connections directly. Honestly, it's an absolute must-have in your everyday DevOps tool belt.
Now, what's really interesting about this slide is how it maps a super common issue to its actual root causes. When you're checking SSL out in the wild, you are inevitably going to run into this real-world error, net.err cert invalid. When your browser throws this, it's telling you that step 3 of our handshake, that crucial verification phase, has completely failed. And there are really 3 primary culprits here. Number 1, an expired certificate. The digital passport is just past its validity date. Number 2, a wrong domain, meaning the certificate was issued for website A, but you're trying to force it to work on website B. Or number 3, a self-signed cert. It basically hasn't been vouched for by a trusted, independent authority. So the next time you see this error, you know exactly where to start your hunt.
Section 5. The DevOps Importance.
Okay, let's shift our focus to why everything we just learned matters so deeply for your future DevOps careers. So the crucial point is this. SSL is not just about giving a user some comforting little padlock icon in their browser. No way. It is foundational infrastructure. If you mismanage your certificates and experience SSL failures, the operational consequences are brutal. I mean, SSL failures can instantly break APIs, completely severing communication between your vital software services. They can block websites entirely, locking your users out. And for those of you dealing with modern infrastructure, a single SSL failure will immediately fail your Kubernetes Ingress, bringing those containerized deployments to a dead stop. The stakes really are that massive.
I want to leave you with this final, somewhat provocative thought to chew on as we wrap up. Are your DevOps workflows actually securely encrypted? Or are your APIs and Kubernetes clusters secretly operating in plain text, just sitting there waiting to be intercepted? Really think about how you're going to apply these foundations to guarantee your infrastructure is locked down tight. But listen, huge congratulations on finishing this mandatory Session 10 task. You've got the SSL/TLS knowledge required to officially move forward to Phase 2. If you found this explainer helpful in your training today, make sure to hit that like button and subscribe to CloudBridge Tech Lab so you never miss a step in your DevOps journey. I will see you in the next phase.